So Select 3 of undecidability. We saw decidability, undecidability, recursive and recursively enumerable languages. Now next is the halting problem. The Turing machine will halt or not on some particular input string. So we have to find out whether or not the Turing machine will halt or it will not halt when you provide some kind of a input string to that Turing machine. Given some program written in Java or C, will it always terminate? So the question is, will a program which is written in a Java language or a C language or any other language for that matter, will it always terminate? So the answer to it is, we can only check after running the program whether the program is halting or not, that is whether it is terminating or not. So we say that halting problem is undecidable. That means you cannot decide without running that program whether that program is halting or not. Just by looking at the program, there is no such algorithm which can decide whether the program will go in an infinite loop or it will halt. Only once you run the program, you can understand whether the program is terminating, that is whether it is halting and giving you the output, or it is showing accepted or rejected message, or it is going in the infinite loop. So this only you can understand after running that program. So for understanding halting problem, we have to understand that halting is a undecidable problem, meaning you cannot decide by looking at the program that whether the program is going to terminate or it is going to go in an infinite loop. So halting is, you say it is a undecidable problem. So the question is, can we design a machine which, if given a program, can find out or decide if that program will always halt or not halt on a particular input? So the question arises, can we design such a machine which will be able to tell us just by looking at the program whether that program will halt or whether that program will not halt? So this is a derivation to check whether there is such a kind of a machine or not. If after the proof you get the answer that there is no such machine possible to check whether the program can halt or not halt on a particular input, then we will say that the halting problem is undecidable problem. So if we prove that there is no such machine in the world which can solve this problem, that by looking at it you understand whether it is terminating or going in an infinite loop, then we say that undecidable halting problem is a undecidable problem. So to prove this, what we do, we assume that there is a machine H and this machine has a program and I is a given a input, and we assume that this machine will not go in an infinite loop, it will halt, or we assume that it will not halt. So by looking at the program, we are assuming that there is a machine which will halt or it will not halt. So what do we have to prove? We have to prove that there is no such machine which is existing in the world which will tell us by looking at the program that it is terminating or going in an infinite loop. So to prove this, we will go in the opposite direction. We will say that there is a machine which is existing. So we are saying that there is a machine to prove that there is not any kind of a machine like this. So what we will say, there is a machine. Say that machine is a H machine having a program P and an input I is given to it, and it will tell us whether the program is halting or it is not halting. So this is the condition which we have assumed, which is opposite condition to the undecidability factor, that the machine is telling it is decidable machine. So what do? We write here that this allows us to write a program. So now we have got a machine, write a program. What is a program? Program is that C of X. C of X is any program. We are taking a different program. C is a program. We say that if H x comma x. What is x comma x? X comma x are arguments. Arguments are passed. X is passed as a program as an and as well as a input I. So P and I is replaced by x comma x, where x is a argument. If it equal to halt, we say that if this condition is satisfied, where h p comma I, that is x comma x, equal to halt, then loop forever. Meaning, if there is a program C which is satisfying the condition where x comma x is equal to halt, then we'll write some statement which will loop forever. So we are writing a statement which is looping forever. That means it is going in a infinite looping. That is infinite looper. So there is a, if this condition is satisfied, we will loop it forever. Else what we will do? Else we will return what? We'll return a statement of exception or rejection. So we are saying that C is a program. If this condition is satisfied, we'll loop it forever, else we'll return accepted or rejected. So now if we run C on itself, now what we'll do? If we run C on itself, now I'm running the C on itself, so I will say C is running on C. I have two conditions. Condition number 1 is H C comma C equal to halt. But what are we saying? It is looping forever. Loop forever. That means it is not halting. So we write here not halt. Correct. And the second condition is H C comma C equal to not halt. But we will say that it will return the value. That means it will halt if it returns some value of exception or rejection. So what are we saying? We are saying that if C runs on itself, then H is saying you that it is halting. But what is the program actually telling you? C is telling you it is not halting. Similarly here, H is telling you it is not halting, but C is telling you that it will halt. So you are contradicting the statement. That means there is no such machine H. Your H assumption is wrong. There is no such machine in the world which will tell us whether it is a halting, it is terminating or it is not terminating. So we say that H is wrong. We say H is wrong. What do we mean that? So we assume H exist is wrong. That means there is no such machine which will tell us by looking at it whether it is halting or not. H was telling you halting, but what it happened? It became not halting. H was telling you not halting, but what it happened? It became halting. So that means the assumption of H, the machine H is deciding that assumption is only wrong. So H is wrong, so our assumption is wrong. So we cannot have a machine. So we cannot have a machine which tells us whether the program is halting or not, whether the program is halting or not. So there is no such machine which exists in the world which can tell you whether the program is a halting problem or not a halting problem. So we say that halting problem is a undecidable problem, because we created a halting and what we saw, the machine was wrong. What was it following? No, it was not following the proper conditions. when the C was running on C itself, it was showing not halting, but the machine was saying it will halt. When C was running on itself, it was showing halting, but the machine was saying not halt. So it was not correct. The assumption of taking H was not correct. So we say that H does not exist. So this is the whole thing about the halting problem. The halting problem is decided, or it is used to tell that halting problem is a undecidable problem. That means you cannot tell whether a particular program is terminating program or it is a non-terminating problem or a programmer. By looking at it, you have to run that program, then only you will understand whether it is halting or whether it is going in an infinite loop.